So my name is Lennart Fransell. I'm a developer advocate from IBM, working with blockchain. I've done so for about 2.5 years. And my job is to go out and talk to groups like you who want to learn more about blockchain, and especially Hyperledger Fabric, which is IBM's version of blockchain in a way. And also to find out what you're interested in and take that back to IBM management. So what I have here is a URL, the repo URL here, which comes to this repo, and everything we need, and everything you need is here on this repo. That's all you need. I also have some URLs up here. The IBM Cloud app, the cloud sign up for Windows no Code is this here. And this is if you want to run IBM Hyperledger or blockchain in the IBM Cloud. So it's good if you capture this as well, because that will get you there, and you can then go, get into the IBM Cloud and begin to work there. And I'll show you how to do that. Code for Code is an IBM initiative. How many people have heard about Code for Code? Anybody? Very good. So this is a free hackathon, if you will, for trying to come up with applications that can help people in need and help to make this better work. It is all free, it doesn't cost anything. If you're interested in doing it, you can just sign up and be part of this thing and have a good time. No money changes hand, you don't have to endorse IBM or do anything else. Just check it out and see what it is. And then if you have a startup company, if you have been a startup company less than 5 years, you can get a lot of goodies at this URL, including cloud credits. So this is what these do. This is not my laptop, but I will try to manage anyway.
You mentioned the startups get cloud services to you?
They get cloud credits if you have been in a startup less than 5 years. And it's a fair amount of credits in other words, so it's worthwhile doing that. You don't have to do anything special, just apply and do that. It's a 10,000 equivalent dollars per month, something like that. So you can run a substantial business on that as you develop your application.
Could you bring that URL back up real quick?
I will do that.
Appreciate it. Let's,
Now, how many people here are familiar with blockchain? How many people have programmed blockchain? How many people would like to program blockchain now, today? You don't know what you're asking for. I'm feeling really good. That's what I wanted to hear. You will have a good time here, I promise you. So let's see what we have here. Okay, that's fine. We have done that already. Documentation. If you're interested in Hyperledger Fabric, which again is an IBM supported version of blockchain for business, no cryptocurrencies. When people hear other work with blockchain, they say, oh, cryptocurrencies. No, it's not cryptocurrencies, it's Hyperledger Fabric. If you click on this link, you get the best documentation on Hyperledger Fabric that you will ever see in your entire lifetime, and that the lifetime of your children and your children's children as well. This is very, very good. This is the official documentation of all open source, called Read the Docs. We're not going to go through that now, but it is really something you should sit down and read. Take a week off, go to the beach and read this link.
Okay. Include videos? Include videos?
It includes very, very nice documentation and pictures. Not videos, but
okay, skip videos.
Yeah.
Okay.
But it's official, in other words. That is the thing that is if you ever come into an argument with somebody that says, no, it's not that way, read the docs, and that's the way it is. It's the official one. Then we have another link here, Hyperledger Fabric. This is to Hyperledger Fabric itself, and I'll talk more about that later. And then to IBM Blockchain. And now you wonder, what is IBM Blockchain if IBM supports Hyperledger Fabric? Hyperledger Fabric is an open source product. Doesn't cost you anything. You can and we're going to use it here today. Doesn't cost you a single cent to use it. You can write very large applications all for free and deploy it on your laptops or anywhere else you want to, and be happy and live happily ever after. So what is IBM Blockchain? IBM Blockchain is the IBM cloud-based environment for running blockchain, for running Hyperledger Fabric, or any other blockchain you're doing. In other words, it's a cloud service. For that you pay money. It's not a whole lot of money, but you pay money for it. And for what you get there is the ability to create an application, deploy it, say in Japan, deploy it in the US, Eastern Europe, United States, deploy it in Latin America, what have you, and have it up and running on real strong hardware. Again, you don't have to have it, you never have to use it if you don't want to, but there it is, and that's the difference. IBM Blockchain is the cloud, Hyperledger Fabric is the non-cloud. Different code bases because the cloud does not include all the Hyperledger Fabric code, but a hosting service, including administration and other things for the Hyperledger Fabric. And I put out a presentation here, and we can start go through this. I'm not going to go through all of it, but we can see what we can do here. If you want me to stop, just tell me. You have my email address here, by the way. aref@us@ibm.com. And if you email me, I will respond. So the first question is, where does blockchain come from, and why did it occur suddenly? And the answer is the global financial crisis 2008. You can see here on the Dow Jones Industrial Averages, this was a crunch time. If that had not been, we wouldn't have had blockchain today. If the crisis hadn't happened, we would not have had blockchain today. This is what made somebody really, really angry. And who was that person? Perfect. Exactly. He probably lost money, or she, it may have been she as well, or many people, lost lots of money on this crisis and said, you can't trust the banks. Everybody says that banks are a trusted party, but you can't trust the banks because here's the proof you can't trust them. And Satoshi Nakamoto wanted to write a purely peer-to-peer version of electronic cash. So that all of you here with that system could send me $10,000 US. It's electronic cash, which I know what you all want to do. And you send it to me directly, peer-to-peer, not going through a bank. I come from Sweden, and I sometimes send money to Sweden. It doesn't go through, it goes through 4 banks on the way. They all take a percentage. So Satoshi Nakamoto said, why can't I send it directly to somebody? Just peer-to-peer, like an email, peer-to-peer. Directly from one part to another without going through a financial institution. He didn't like banks. He wanted to see no goodness that they provided, no additional service they provided. He just said, I want to send it like an email. He had digital signatures. So they existed 10 years ago. But he didn't have a way to stop double spending. And double spending is if I have a PDF file on my laptop and send it to all of you. I send the same PDF file, I can then send the same PDF file to another group of people and to another group of people. I can send it to as many people as I want to, because there's nobody who can see who owns the PDF file. The same with cryptocurrencies. There was no way to prevent me or you from sending the same cryptocurrency, to send the same $10, say, to 1 million people. Because there was no way to show so that you who sent this money didn't own it anymore. If you send me $10,000, I have it, you don't. Double spending is when you still have it, and there's nobody who will decide who has it, except the banks. Now we're back to the banks again. So he proposed a solution to the double spending problem using a peer-to-peer network. That's Bitcoin and that's blockchain, 10 years ago. Any questions? If you understand that, you understand everything there is to know about blockchain and Bitcoin. Yes?
Yeah, the PDF file is not good example.
It was a best example.
Because digital rights actually can leak. Yeah?
Right. But anyway, that's what he wanted to do, and that's what. Then we got two things coming out of this thing. One was cryptocurrencies and Bitcoin, and we're not talking about Bitcoin and cryptocurrencies here. We have nothing to do with that. We are talking about the infrastructure, which is called blockchain. We can send anything we want to in blockchain. Yes.
Can you make a quick statement about the IBM stablecoin they released in the past week?
I'm sorry, IBM's?
Stablecoin.
They released this like a fiat currency based stablecoin past week.
I heard about it, but I don't know any details. Not yet. And if you haven't read, I'll tell you some more about this as we go along here. If you want to read about this, read bitcoin.org, bitcoin.pdf. This is the paper. And if you have read this paper, you understand everything there. So it's a very, very good paper. It's 9 pages long, very short, but very, very clear in what you want to do. And that's something we will have to do. The blockchain story. So here now, you may know this, but this is a good way to begin to understand what this is all about. In the old days, we had ledgers. We had ledgers for 2,000 years. If you have a checking account, you have a ledger where you enter what you send somebody, what you pay somebody, and what you spend, and what you get in, what you acquire. Everybody has ledgers, and the world is based on ledgers. IBM has ledgers for the tens of thousands of business partners we work with. And what happens at the end of every year? We have to put in the accountants. And the accountants have to make certain that all the ledgers are in sync. And that is very, very complicated. It takes a long time, costs lots of millions of dollars, because they are very seldom in sync. Which is why we got the blockchain ledger. Here we have 6 parties who are all doing business together. They don't have 6 different ledgers, they have one ledger, one single ledger. So if all of you represent one company and I represent one company, we do business together. We're all using the same ledger. So before we can put anything on the ledger, you and I will have to agree. We will have to agree, yes, this is correct. And it means that there is no reconciliation needed because there's only one ledger. This is a fantastic innovation that nobody had ever thought of before, at least not to my knowledge. And this is the cornerstone of blockchain. One ledger. That also means that if you don't have a number of companies working together in a business network, there's no point in you coming and saying, let's use blockchain for this. Only if you have a group of people representing different companies doing business together, does it make sense to use a blockchain. Otherwise, don't use a blockchain. Stay with what you the old and true databases and so forth and so on. But if you have something like this, if this fits your bill, then you can say this fits for blockchain. It's very simple and very, very easy to remember. Hyperledger. Hyperledger is a version of blockchain run by the Linux Foundation, open source. It has a number of components, of which Hyperledger Fabric is the one that IBM supports. We also have Hyperledger Sawtooth, supported by Intel, and others as well. Then we have a number of tools, of which Visual Studio Code is the most important one, at least for this meeting here. These are the tools that you learn to use to create applications. in say Hyperledger Fabric. So Visual Studio Code and Hyperledger Fabric are the two components we'll talk about today. Then we also have an application layer that you may or may not be familiar with. Have you heard of trade lens? Have you heard of IVFoodTrust? You must have heard of IVFoodTrust. That's actually, and I'll show you an example of this. This is actually a very important product where you can now, thanks to blockchain, determine where the food comes from and if anything happened on the way to you. When you get a stomach ache at the end of the day, and you want to find out, could that possibly be food poisoning? You can now go and search through the blockchain from the farmer that created the lettuce that ended up in your salad. And this is a very, very important first application of blockchain that has taken over, actually. I mean, it's very, very, very big. And it's called supply chain. And supply chain is the thing that makes the world run the way it does. Apple, for instance, is very famous for its supply chain. Tim Cook was the head of the supply chain for Apple for many years before he became CEO. And about half of all the applications I can think of are supply chain. So again, if you can cast the problem you have as a supply chain, you have everything you need already done, use cases and everything else. And that's the first step. Make certain that you really need blockchain for what you want to do. It is not cool to do blockchain because if you fail, everybody will laugh at you, and that's never pleasant. So therefore, look for use cases, and again, supply chain has proven itself again and again to be very successful for Hyperledger Fabric and for blockchain.
I have a question on this. So the top of the diagram, the house thing is the Hyperledger.
This is an umbrella name.
Is it? Oh, it's the umbrella name, and you have the instances, is it? These are different instances for different purposes?
These are different products. Different products. And it's an open source family of products, so to speak, so that these are quite different. And they're simply all living under the umbrella name of Hyperledger and supported by the Linux Foundation.
So if I want to do something for, let's say, clothes or something,
yes.
What do? I take the main template Hyperledger and customize it with the fields such as textures and things like that, and call it Hyperledger cloths or something?
No, that's a very good question. The way you do it is this: you decide which one of these products you want to use. So these are different products. Mm-hmm. And you simply have to see which one you feel is the one that meets your requirements best.
What if I want to do a new one?
If you want to do a new framework like this,
yeah,
you're free to do so. You would not probably want to do so because it will take you quite a lot of time and a dedicated team, but you can do it, yes, absolutely.
But I would imagine if there is something like this, it would start with that a basic raw form, and you will create an instance of these things to suit your needs.
No,
so,
it may appear to be that way, but it really isn't. It costs in real money millions of dollars to create one of these frameworks.
Because of infrastructure.
Because of infrastructure, because there are people who are, although they work for free, still have to be recompensated in some way or the other. I mean, again, don't get me wrong, people start up companies all the time and create new frameworks and other things. But for us here, since I assume are interested in the business kind of type of end of it, we want to write an application that can do something in the business setting. We can select one of these, and it depends on what ones we think will meet our requirements the most, and maybe use some of these tools, and then we begin to code in Visual Studio Code. And I will actually show you how to code in about another 10 minutes.
yeah. So if I have to start, give me a couple of steps. Like if I have to start one more thing for clothes, would I take a basic one? Is there a basic sample in there, or should I?
Hold your question because I have the answer.
Okay, thank you.
One more question.
Yes.
How is the frameworks and tools, do they relate to each other or are they independent?
They relate to each other in the way that they all are part of the same family of products, and they all are run by the Linux Foundation.
Okay.
And they get some benefits from that, of course, but otherwise they are quite different. For instance, here is decentralized identity, which is very, very important. Hyperledger Indy has nothing to do with the Fabric feature. So this is the most advanced so far because the most money has been put into it, so to speak. And sawtooth is maybe number 2, and the other ones are also.
So choosing the tool, is it local particle vendor or the Hyperledger?
I'm sorry, sir.
If you choose particle tool, let's say particle tool,
Yes.
are you bind it to someone, or you're free to move today?
You can move. These are very good questions, and I'll tell you something interesting. I do lots of these events. I have not gotten these questions before, so thank you for that. That's good. And yes,
So all of those products run on the Linux OS?
they would all run on the Linux OS. Yes, and they're all open source.
Perfect.
That's the only thing really they have in common.
Great.
Yes.
And then the language to implement one of those frameworks, once you're on top of Linux and you get Hyperledger Fabric, then are you coding in Python or C++ or anything?
Python and Node.js and a few other languages as well, Java. Let me continue here because we can load that. Hyperledger Fabric looks like this. It has a ledger, and we can just leave it at that for the time being. It is very strong on cryptography. Everything is totally secure, bolted down with cryptography functions. And we can go through those later, but I mean, it's just remember that it's all made double, triple, quadruple safe. Don't let anybody believe that, don't let anybody make you believe that they can hack into this thing because it is almost impossible. Nothing is totally impossible, but this is very, 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 very strong part of Hyperledger Fabric. Consensus, we can talk about that later. And business knowledge, we will show that as well. The point is that it's a plug and play. You can take Hyperledger Fabric and you can change the cryptography, you can change the ledger, you can change these things, and you can take something and put it in and remove something like that. And that is very important because when you may say, okay, I heard this guy talk about ledger, Hyperledger Fabric, I want to use that, but I don't like the cryptography algorithms they have, no problem, put something else in. That is very important, this plug and play. It is not just that you have to take this thing and not argue, just do it. No, you have the right and you have the ability to simply just move things around as you want to. And that's what people are doing. So that my version of Hyperledger Fabric may not be your version. They will behave quite differently.
Including consensus.
Yes.
So does it still guarantee a strong cryptography?
Yeah, you wouldn't go in and weaken the cryptography. But I mean, so it would still guarantee the strong cryptography. But the point is that you have the ability to change what the focus is. And I have some examples of that. For instance, let me wait until I come to that. But it's if you are really strong technical, if you're a strong computer architect, so to speak, software architect, you will may have some focus that I don't have, and we may be equally good and equally whatever. So you say, no, in my case, for my cryptography, I need to have this thing rather than this thing. And that can be important if you are in the business field and you are targeting different audiences.
I would imagine a lot more customization happens in the consensus layer, right?
From the
A lot more customization happens in the consensus layer.
yes, I mean the point is here that the entire system is based on the ability to take something out and put something in instead, based on what you're with the same APIs, right? So it's so the same APIs. You can take something out and plug something in because you want something else, or let's write something from scratch. So here we have an example of the pluggable consensus. It allows the platform to rely on well-established toolkits for crash fault tolerance. Okay, so that we're running now Hyperledger Fabric and the electricity suddenly goes out. So we have a crash. We can then have a crash fault tolerance in that in the next building we have another computer running and that where the electricity has not gone out, and we can simply do failover to that and we keep running. That's crash fault tolerance. You can handle crashes. If a system doesn't have crash fault tolerance, I mean, you don't try to touch it, because I mean, that's it. Byzantine fault tolerance means that you can handle somebody trying to actively break in and subvert your system. The details of this are quite complicated in a sense, but that's what it means. We can handle somebody trying to break in and take over the system. So these are examples of pluggable consensus. We may say that, oh, we don't worry about this. We're running an alpha or beta release of this thing. We don't have just-in-time fault tolerance. We live at the risk of that. Or we say that for crash fault tolerance, well, we always need that anyway. So this is the way, again, where you're focusing on certain things and not other things. You may select different types of consensus. And then we have something called raft consensus ordering service is coming in this year or next year. So here's the blockchain. The blockchain is simply a list of blocks, starting with the Genesis block here, and then block B1, B2, B3, with transactions. And that's pretty much what we in blocks here. And that's pretty much what we need to know. What we need also to always need to remember is the fact that what happens if I remove or try to change something here?
A hash will differ.
Yes. You will know it right away.
Alright.
You will know it right away. If it's your system and I try to change something, a red flag will immediately show up. Yes?
I'm really sorry, but sometimes if you keep the ledger, the mistakes appears or errors. How is it possible to correct it?
No, you cannot change anything in the ledger, in the blockchain itself.
So, but because like the errors is it's happened in the life, especially if you're going to use an application, So
okay.
how we can deal with this? So it means if something.
No, go ahead.
Yeah, like I'm just trying to figure out, for example, if you're going to have like title of real estate and you want to put on a blockchain, but sometimes they even misspell the names in the titles,
That's the thing, is it right once and there's no undo to fix it.
There's no undo, yes. But what you can do is you can update it. So let's take an example. Now, suppose you write down that the cost of this office building here is $10 million, and actually you meant to say $9 million. So now we have $10 million in the blockchain. We can write a new entry for that, saying that at 10 days later it was discovered that the $10 million was wrong. It should be $9 million or whatever. So we can make another entry for the same price, but the original still stays.
So it means it's going to be the whole procedure would happen like they kind of one by one.
Right.
Two entries.
Two entries.
Two entries.
Yeah, but now you say, now we changed the blockchain. Well, we have not actually changed the blockchain because we could go in and see that on March the 1st, the value actually was $10 million. Now it's $9 million. But we cannot erase the original entry. That's the key.
It's good. It keeps audit. Right? It keeps the audit.
Yes, exactly.
So that way you have traceability as to.
And that can be. That's very important because if we can change, for instance, let's take an example now. Let's say, suppose we have a voting system where if one party wins an election, and it turns out to have been faked, then it must be possible to then write the new vote count in, which we can do, but we cannot overwrite the original. The original is always stays there.
That's the error, the accident on the ledger system, but on the smart contracts, if somebody puts in something wrong and somebody agrees to it on the other side and the contract's now live, it can't be hard to undo it unless both parties agree to, right?
Well, okay, so you come, I'm glad I can get all these questions because this shows that you're really interested in this subject, which I am as well. But one thing also is that if we now together say, we had such a great time here in San Jose last night, that we're going to form our own company, our own blockchain company. And we have a set of, we all represent various companies, and we have therefore a set of companies collaborating on blockchain. We can make decisions that are not in the best interest of honesty and so forth and so on. We can create a blockchain that is just an evil blockchain if we want to. So the point is that there's no God-given truth in this thing. If we follow the rules, it's going to be a blockchain that behaves the way I described it, but if we follow some other principles, it's going to be an awful blockchain that maybe creates nothing but erroneous results.
But main principle will stay, you couldn't change the record. Whatever we rule define, the principle, main principle.
Exactly.
The chain will stay.
The chain will stay the way it was written. There are interesting questions about it. What happens if the blockchain becomes too old and we want to maybe move it to other systems or something like that? Could we change it after, say, what happens when you discontinue it? And I can talk, since we're talking about these questions now. Suppose we want to write a blockchain for medicine, for healthcare, for X-ray images. And we say, that's great. We store all the X-ray images on the blockchain. And everything will work fine. Nobody can cheat. Nobody can come up to say that you have the wrong X-ray. What is wrong with that, running a blockchain on the X-rays? Yes?
It's extremely bad idea to put PII in public information.
It is absolutely asinine. It's the dumbest thing I've heard all day, isn't it?
Oh, you haven't had a very good day.
I haven't had a good day until now. Actually, I'm having not so good day until now, but now when I meet you guys, I have a very good day because this is interesting. There are two reasons you cannot put X-rays on the blockchain. The first thing is that you cannot put any personal information on the blockchain. The second thing is that you can't do it because they are too big.
It's what?
They're too big. They are enormous.
Enormous, yeah.
So you see, the more you tie down the blockchain with large data blocks, the more longer time it's going to take to traverse it. So what you do instead, you want to have a pointer from the blockchain to an external system that has all the X-rays. And this means another thing. When you suppose we now say we now know what we want to do for the rest of our lives. We want to create a blockchain system that handles something, whatever it is. That's probably not going to happen. The blockchain will only be a small part of the data storage for our system. Most of the data that will probably stay where it is, outside, and we will point to it. Because the blockchain has to be running like a bat out of hell, to use the technical term.
So it means we do not put the stuff inside, but we kind of secure the path to that stuff.
Right.
And nobody can go.
Nobody can go in and get them that way. And first of all, it's against the law now with GDPR to have names and addresses and so forth on the blockchain. But second, even worse, if it can be even worse, is the fact that we cannot have these large data blocks because we have to be able to traverse. And if we have to traverse it, and if it takes an hour to traverse it, we're going to be not very happy.
But those files are linked somewhere else, and there's files where they're hosted can be corrupted, right?
Now we come to the interesting thing: how safe are those systems?
Mm-hmm.
And there we simply have to ask them to say that we have to trust them in some way. But you see, very soon we say, because Satoshi Nakamoto said we don't trust anybody, he said. And now here we're saying after just a few minutes that we have to trust somebody, and so we trust the medical record people. And that means that there are some trade-offs here. Who shall we trust and who can we not trust? If we don't trust the banks, why should we trust the healthcare systems? Fortunately, I don't have to answer that. Here we have, first of all, how many people here now really want to start coding? Coding. Sorry, start coding.
You mentioned you were speaking from Sweden.
Do you want to have a few more here, if charts, or do you want to start coding? Because we can start right away. I mean, it's...
I like that
To
slide.
understand the concept.
Right, okay. This is the way the heart of the Hyperledger system it has been architected. We have certificate authorities here. To join a Hyperledger system, you have to be a member of the system. It's like joining a country club from the Midwest. You have to be admitted. If you don't admit it, forget it. You're not one of us. Applications or have users. So if all of you represent the company, collaborating here, you are here, you use an application, an SDK, and you send data that you want to put on the ledger to a peer, which is a node on the network. It goes to the endorser, who will run through this information and see if it actually if it fits the blockchain. And if it says yes, it will send back information saying everything is fine. The application will send a note and message to the ordering service that will order the applications, the messages, and then put them on the committer that will commit the information onto the peer. And the peer is running the ledger and running chain code and emitting events. This is much more complicated than what I can explain in a very short time, but this is the key about how everything works. And the one way of understanding it is that it's all automated. There's no trusted third party. Everything is automated. This is either it works, the endorser says yes or no, and then the commissioner commits it. And this is what Satoshi came up with, a way to make certain that everybody has to endorse. We all have to endorse what goes onto the ledger. All of us our systems have to endorse it. And it's very, very interesting. The good news here now is that we don't have to understand this to use it or to write code for it. Because as coders, all we have to do is to write smart contracts. And they don't have to understand this thing. Because very often when you say that you're into blockchain, you meet people who want to talk about this thing, which is very important. But we can get started writing code without understanding exactly how the ins and outs of this thing. Because the chain code exists as it is. Yes?
So the application is actually sitting on the node, right?
Yes. The application really are the smart contracts. And they are typically rather, if you have a chance to see those, they're typically rather straightforward. They had what were they called? On old-fashioned databases, they had, I remember what they were called.
Triggers.
You could write code that was running in the database.
Stored procedures.
Store procedures, exactly. These are store procedures. If you know store procedures, this is what this is. The smart contracts, just a jazzier name. Here we have the ledger. So the ledger is here. It consists of the blockchain, because these are confusing. The ledger consists of the blockchain and the word state database, which is a database that contains the information from the last blocks. And the reason you have this is because you can, by accessing the data through the word state database, you can get there much faster than traversing block by block, rather than to serial access. You can just go in here, get it, and be out there in a second. So the ledger and the blockchain. The blockchain you don't really see, the ledger we see, and then we have the word state database. And here we have, again, I like this chart, chain code or smart contracts. You write them, they add records to the blockchain and also to the word state database. And the word state database can also be used for finding information that has been deleted. You can delete things from here. Okay, so now we come to something more interesting, maybe, or less interesting. Suppose we now decide to develop a Hyperledger Fabric application. Where do we start? A business problem that cannot easily be solved with existing techniques. That's the first thing. Do we have such a business problem? If we do, we can continue. If we don't, let's talk about something else in this. An identifiable business network with a shared ledger, with participants, assets, and transactions. If we have that, we should begin to use blockchain. Otherwise, it's not the fit. The need for embedded trust, but no trusted third parties. If somebody says we have to have this thing because we need a trusted third party, tell them to go somewhere else. If you have money, if you have lots of money, which I'm certain all of you do have, you can go to the blockchain garage. I have some very good friends there in San Francisco, who will help you create your own application. They want you to pay them some money for it, but I'm certain it shouldn't be any problem. Large companies typically go to the blockchain garage. They're very, very good people. The reason I mention them here is not because I want you to go there necessarily, but because they have a very good website. Their methodology is written on the website. If you want to learn a professional methodology for writing Hyperledger Fabric or blockchain applications, simply go and look at the URL. Blockchain services. Everything is documented there. Then reuse existing blockchain use cases as step number 1 after that. You can select industry, you can select solutions area, and so you can select the search fabric, search topics, and you can see which use cases exist already. If you already have a use case that's similar to what you want to do, you know that you're doing the right thing, and you can just take that use case and develop on it. Do not start and to try to start from scratch. Do not start from scratch. Beg, borrow, and steal anything you can. If you don't do that, you're going to be very sorry, and your friends will desert you, which is not very happy, not very good situation. This is where you start. If there is no use case for what you're looking at, it might be good, it might be bad. But if there is one, at least you know you're on the right track. Leverage existing frameworks and libraries. Okay, this is another very important point. Hyperledger Grid here is a very important new application that is coming. It's a framework that will help you for creating applications. Again, you don't want to start writing code. You want to start using products like Grid that can help you reuse existing components. If you're interested in cryptography, you can reuse components in the URSA, the Hyperledger URSA library. IBM FoodTrust, if you're interested in that, or digitizing the global supply chain, which is the IBM shipping product. Leverage, reuse. And so far we haven't written a line of code. Then we have code patterns. My friends up in San Francisco spend all the time writing code patterns, which are open source on all on GitHub. You can take them, you are encouraged to reuse them, and if you find a fit, you have the code ready for you to go, for heaven's sake. So far we haven't written a single line of code again. This is very, very important in my opinion, because I mean, if you run a startup company this way, you just big borrow and steal. You can do other things without spending a single cent. Now, so far we haven't spent a single cent. We just looked around and taken a look at what is available, and then hopefully been able to snag something. And this is the way to do it. Last year when I met people who wanted to start, they said, we're going to start writing code now. And I said, we have a design? No, we know what we want to do. They said. And then they came back about 6 months later and said, well, it didn't work out, which I could have told them anyway. So this is more than just it. There are many more of these. See if they fit, and if they fit, then you have the starting point of your application. Use Visual Studio Code. How many people here know about Visual Studio Code? Very good. That is the development environment where you use, and the blockchain platform for Visual Studio Code. All free. And here is what you do with Visual Studio Code. You create smart contracts, you write smart contracts, you package them, you export them, connect to local Fabric runtime, and you tear down. Everything is, except for the Fabric runtime, it is just smart contracts, smart contracts, smart contracts, smart contracts. That's all you're going to write. And if anybody wants to talk about cryptocurrencies, tell them to go somewhere else. And now we're going to take a look at this thing, and after that we can code. We can stay all night, Olga has told me, so there's no problem. So here is the blockchain. This is the coffee blockchain. It's a real use case, and you can actually run it. You can buy coffee from the Ethiopian Irkutsk coffee. And here is what the blockchain looks like. It's a batch ID, fair premium invested. They have invested $182,000 from the money they made, investment amounts, organization description, report name, report year, and transaction ID pointing to the blockchain. Not very important here, or interesting here, but we can continue here and see what the next one looks like. Now we're exporting the blockchain, or the coffee, I should say. Now we have a bill of lading number, container number, which has been deleted, I don't know why. FDA number, ICO lot, invoice number, issue date, loaded vessel, we can see which vessel it went on, seal number, vessel voyage number, timestamp, batch ID, and so etc. etc. Everything is here. And what does this mean that it's here? First of all, they have removed all the old-fashioned paper documentation. Everything is now digital. We can search on this thing. That's what blockchain is called. We can search on this thing. If we want to, if something went wrong, for instance, here we can search which vessel was it that transported this thing, and we can just look for PL loaded vessel, and we'll find out for this it was Northern Man. That is what makes Hyperledger and blockchain so powerful. You can search on all this data because it's digital that you are saving. Yes?
So for example, line 14 had the author's identification.
Yes.
Okay.
Everything is there. And this is what a real blockchain looks like. And what they do, in order to create this, you have ripped out all the paper and instead digitized it and put it here. Because I mean, now you can say, okay, we have it here, what are we going to use it for? And here we have the original document. So they have digitized all these things and putting it. Now it's imported in the US. Bags expected 150. Coffee batch. Condition, no condensation and no hole in container. Date script, insect activity, no insect activity. Again, all of these things are there as smart contracts you can use to search to see here, is everything okay? Has anything happened? Did we lose a bag, for instance? You can see right away. And that's what you keep writing, this code. Coffee evaluated. Acidity is 8. Aftertaste is 8. I have no idea what this means, but it must be good. The aroma is 9, even better, etc. etc. Now, if you can imagine, this is a coffee application. We could change this to be anything we wanted to, right? Yes.
So about coffee, because it's like different part of shipping product, it means whenever you touch this coffee should add this is blockchain, or it's just can, okay, like for example, production is this blockchain, like transporting this blockchain.
This is one blockchain.
Just one from the beginning.
From beginning to end, yes.
It means the whole part of this, chain should be involved in this project.
Right.
Others, everybody is ready or not yet?
That's my understanding. I can easily verify that, but that's my understanding. You can have more than one if you want to, but I mean, it's not very much information here anyway.
Yeah, that's true, because it's like.
So and it's also interesting to see here because one doesn't always think of this that it has to. If there was no way to search it, the blockchain wouldn't exist. But it's a search that makes it so powerful. And now we get to IBM Cloud. If we have something like this running, we can run it on our laptops, we can run it on our hardware, but ultimately we want to run it in the cloud. It doesn't have to be the IBM Cloud. We support almost every single cloud in the universe. But here you get a very nice console. We have orders, CA, peers, etc., and we can then very quickly add new peers, add new concepts to this thing. We have members, channels, notification APIs, etc. And we're sitting in front of a console here, and we can just plug and play and click and point, and quickly get a very powerful blockchain up and running in the IBM Cloud.
So did you say the IBM blockchain could be run on any hardware, like on-premise?
It can be run on-premise, yes.
So what is the license terms? It's open source, MIT, GPL?
This is open source. And here you can see something interesting, and this is something you should be aware of because this is not immediately obvious. Hyperledger Fabric runs on every single cloud under the sky. These are just the latest ones I have seen. There are many others as well. So what does that mean? They compete with each other. What does that mean? It's a race to the bottom. It's a furious race to the bottom. I looked at the Oracle Cloud, which is very nice. They're all very nice. But everybody sees this thing now as a big, big business. Because blockchain is bigger than you could ever imagine. I mean, some of the applications being written are gigantic and will change the world really. So therefore, all the clouds want you to run on their cloud. And what is the best way to do that? First of all, give them features they will kill for and lower the price. So if you are now going to start to write blockchain code, you need one person on your team to keep track of the clouds because they can save you lots of money by simply suddenly switching to another cloud, maybe. It's just something to be aware of. And here we have the IBM Enterprise Blockchain Platform running in the IBM Cloud. You can run it on premises. And we support Amazon Web Services, as you can see, which would have been impossible even a couple of years ago. Development tools, DevOps, one-click network creation. Just one click and your network is up and running. And then the operational tools. This is where the money goes to make the most interesting and the most powerful platform for in the cloud. And that is what I had here. You have access to this thing as well. So. All right, now we'll see what we can do. Those of you who like to code, let's start. Create a network locally using IBM Blockchain Platform extension for VS Code. The first thing we're going to do here is to check the prerequisites. And I want to make certain I put this very as bluntly as I can. If you don't meet the requirements, the prerequisites, you will be very, very, very sorry. Your friends will laugh at you and your parents will probably spank you. Because the problem is that you have to really, really meet them. You can't just say, well, for instance, if it says 126 or greater, it doesn't mean something else except 126 or greater. V2.x means V2 plus one other digit, so etc., etc. So these things have to really be, this can destroy any number of very, very nice days and evenings if you don't get this right. You can write this thing on Windows. It is preferable to do so on the Mac or on Linux. But if you have a Windows machine here, befriend somebody who has a Mac, or pretend that you like them and just try to cycle up to them, and you can work together. And then what we will do is that we will clone the rep, and we have step-by-step here. Package the smart contract, set up network locally, and run the application. Then if you really want to show IBM how much you like our stuff, the next lab after this does exactly the same thing, except it runs it not locally, but in the IBM cloud. All for free. But I think it's best to start here with this one that sets it up locally, because there are a number of reasons for that. First of all, there are quite a few of us here, and I'm not sure how good the Wi-Fi is. I'm certain it's excellent, but it may take some time to get everybody to download things. And then something I wrote a Medium post, a post on Medium about that earlier today. People are having lots of problems with this VS Code. Not that it doesn't work, but they can't figure out where things are. Because there are buttons to click and so forth, and then there are different personas. And we'll see what you guys think. But this should take about 15 minutes. If you've done it once. If you haven't done it once, it can take you the rest of your life. So why don't we start here and work in teams and start with the prereqs. And we'll go from there.
I don't find